Hello everyone and welcome to today's AusMine webinar. I'm Tim Buckley, AusMine Membership Manager in South Australia, and I'm pleased to be your host today. Before we begin, I would like to acknowledge that I am hosting this webinar from the lands of the Kaurna people. I also acknowledge the traditional custodians of the various lands on which you all work today and the Aboriginal and Torres Strait Islander people attending this webinar. For this webinar today, I'm joined by Professor Peter Murphy and Professor Colin Hall. Professor Peter Murphy is the Director of the Future Industries Institute. Peter is also David Klingberg Chair in Energy and Advanced Manufacturing. He was appointed as one of UniSA's inaugural industry professors in recognition of his extensive research engagement with private industry at a local, national and international level. Professor Colin Hall is an industry professor at the Future Industries Institute and is a key member of the Materials Engineering Group. He is interested in helping Australian manufacturing be globally competitive through the uptake of innovative research. His approach to research is focused on identifying new materials or enhanced ways of using existing technology to solve problems, specifically focusing on additive manufacturing and coatings for industry partners operating in space, automotive, mining, agricultural and medical. Their presentation is on surface manufacturing for mining, the Surface Manufacturing Cooperative Research Centre proposal. This webinar is a discovery of the support and resources offered by the University of South Australia to fuel innovation and propel METS organisations forward. This webinar will delve into groundbreaking advancements in surface manufacturing and how they can directly benefit your business. Discover the potential of surface technology and the global market opportunities awaiting the METS sector. Following the presentation, there will be an opportunity for audience questions and answers. You can use the Q&A button at the bottom of the screen to send through your questions at any time. You can also upvote on another audience question that you most want answered. So without further ado, I would like to hand over to our first presenter, Professor Peter Murphy. Welcome, Peter. Next slide, please.
Thanks, Tim. Thank you. So it's our pleasure today to be able to speak to you about this CRC proposal that we are looking to have other companies join. A CRC is a wonderful vehicle for industry to engage with the research world and to tackle problems that are real-world problems impacting your business today and tomorrow. So firstly, a little bit about UniSA. So UniSA is South Australia's largest university by student numbers, established in 1991. We undertake much world-class research with a particular focus on industry engagement, and we collaborate with more than 2,500 industry partners. The Future Industries Institute, where I am from, I'm the director of the Future Industries Institute. We operate across 5 sectors that reach out into industry broadly in the areas of healthy environments, high-tech manufacturing, which includes areas such as defence and space, medical technology, smart energy, and sustainable resources. And so for the audience today, it's that last one, sustainable resources, that is going to be the point of most interest to you. The Institute is located at Mawson Lake, so it's about 12 kilometres to the north of the Adelaide CBD. And what makes us particularly special is we have more than $80 million of fabulous infrastructure to support projects with industry partners. I will add at this point that the Future Industries Institute also has many staff who've actually worked in private industry, and Colin and myself are 2 examples of that. Both of us have spent a decade or more working in private industry before we came to the university. So a little bit about the Cooperative Research Centres scheme. And this scheme was established right back in the 1990s under the Hawke Labor government. It was one of their initiatives. It's been an enduring scheme, so it's well over 30 years old now. What the scheme aims to do is to create really strong links between research and industry. And there is a genuine focus here on application of the research to solve real-world problems. So if you think the universities undertake a mix of research ranging from blue sky research through to applied research, the CRCs in particular tend to focus more so on the real applied research. Having said that, they also support PhD projects as well. There are two types of CRC grants. There is the very large CRC grant scheme that can run for up to 10 years, that is typically able to attract a budget of industry partners, university partners, and government funding of anywhere between typically $60 and $150 million over 10 years. And then there are separate grants called CRC-P for project grants, which support shorter term industry-led collaborative research up to a maximum of 3 years. So there's two ways of going about this. For the large CRC grants, which is what we're here to talk to you about today, the proposal we have is for a 10-year CRC. So we're tackling medium to long-term challenges faced by industry. We are actually working and solving industry-identified problems. Often, I'll be frank, I've heard criticism where universities tend to develop a solution for a problem that they think exists. What's really different about this scheme is that we work with industry. The scheme is for industry, by industry, to solve genuine industry problems. So it's really well industry informed. There is an education and training program within CRCs that aims to build, I guess, the workforce of tomorrow, particularly PhD graduates, PhD and master's graduates. And we also have an objective of working with small to medium enterprises. So as we know, much of the Australian workforce exists. In fact, 97% of it exists in small to medium enterprises. So one of the things we indeed look to do is to build partnerships with those particular part of the business world. In this CRC that we're pitching to you today, and Colin will talk more about this later, but you will often hear there are debates about intellectual property and who owns what from research. With this CRC, we are looking to vest the ownership of the knowledge created in the industry partners. So if you join us, we want you to own the IP and to use the IP. How do CRCs work? Look, there is a mix of contributions to CRCs. So if you wish to be a partner, there are contributions from, in this case, it would be university research partners. There would be cash contributions from industry partners, and that is all then matched by the federal government through the CRC scheme. So it is a way of leveraging your funding, and that's really one of the key things about this scheme. It leverages your funding investment and lets you tackle problems on a scale that you probably can't tackle by yourself. So what are the benefits for industry? And what we've got here is a particular example. So sitting inside the Future Industries Institute at the moment, one of our staff members is actually the Chief Scientific Officer for one of the current CRCs, which is the MINEX CRC. His name is David Giles. Again, he's someone who's built his entire career around really applied development of technology. This is a great example, this particular project, which has gone through a couple of CRC lifetimes. It's into its second lifetime. What they have made one of their focal points is developing a technology called coiled tube drilling. And this is to really revolutionize how we go about exploring what lies beneath the ground. And within the Australian environment, we've really only to date found much of the material that sits at the surface of the earth. More than 80% of the country sits there largely unexplored. Drilling holes is expensive. There's also an environmental aspect that we must consider these days. So this particular drilling technology that they have developed is portable. It's much, much cleaner and greener than any of the existing technologies. So it uses a closed loop fluid system. And, for going out in remote environments, that's particularly important. That technology is called Rock Explorer. It's currently, there has been a partnership signed with a company to actually build these units now. And it is also part of the National Drilling Initiative. So we have a full team of effectively mining engineers employed through the university, through the CRC, this CRC project, who are now out in the field. They're out in the field currently, conducting drilling trials. What I'd like to do next is introduce Colin Hall. So as I said, Colin worked in private industry from 1995 through to 2004. He has a PhD in materials science that he obtained back in 2014. He won the first ever version of the Prime Minister's Prize for New Innovators in 2016. And that was for the creation of a shatterproof car mirror that has since been commercialised, and was a product actually manufactured here in Adelaide by a local company and then exported to the United States for implementation onto the Ford F-250. Colin is the current president of Materials Australia, the South Australia branch. And I guess, like myself, we came to the universities to engage with industry. That is our passion. And we want to see industry, work with industry to develop technology and actually see that technology put to use to make a real difference to community and in the marketplace. And with that, Colin, I'd like to hand over to you.
Thanks, Peter. Thank you very much. I'll get stuck into the next slide. So why are surfaces and why the surface manufacturing CRC? We see it to be competitive in today's international market. We see that a product or process must be customized to its application. If you look at market trends currently across the world, customization of products is a big trend, and it leads to differentiation and growth potential. We see that surface manufacturing is an easy way to achieve this customization. That is tailoring a product or material to work in its environment. And I think that's a very key point for the audience today. What's also interesting about that is when we start looking at surfaces, the research approach, the equipment, the expertise is all similar across many fields and across many types of coatings or surface treatments. And this is really perfect to be supported by a CRC. So for today's audience, if we're looking at the mining industry and we're looking at where surface manufacturing can be used to overcome wear, globally it's recognised that wear can take up to 3% of a country's GDP. So for Australia, this represents about $30 billion. If we can minimise wear, we can minimise that cost to Australian economy and to business. Wear-associated productivity loss specifically in the mining industry is estimated to be $1 per tonne of processed ore. So if you just think about iron ore by itself, that represents about $1 billion. So within this talk, I'll give a little bit of a case study around some of the work we've done in this area. I'll explain the types of areas of research the CRC is interested in, and then get into some more details about the CRC. So this is one project that was funded through a CRC, the Intelligent Manufacturing CRC, which is just wrapped up. That was a collaboration with a company called LaserBond, who do hard facing. They are interested in minimising wear and corrosion and extending the life of products. In this case, slurry pumps, as you can understand, a very aggressive environment. You've got water, in a salty or aggressive, sometimes acidic environment, so that can lead to corrosion. You've got particles, small to large, which can present erosion and impact. And this all leads to a very aggressive environment, which leads to parts to wear out relatively quickly. We looked at a number of components within this project to understand their wear mechanism. And then we looked at a range of coatings that could be implemented on these different components to minimize their degradation and maximize their life. As you can understand, these large pumps are, it's expensive when you shut down the processing plant to do routine maintenance. They're large, bulky, and repetitive maintenance is costly. So any way of extending the life of the components of these large pumps is a worthy target. So we looked at coatings on the face of the throat bush, on the shaft sleeve, on the liner, the exit for the liner, and to a lesser extent, the leading edges on the impellers. How we went about this, the CRC funded us to work with LaserBond to optimize their coatings, both within the laboratory, but also the CRC funded field trials. So that meant that we could get our coated product out in the field and do real-world trials, which is an integral part and critical in developing new technology, but one that's often very hard to achieve. With LaserBond, their expertise is laser cladding. So that's a laser-based weld overlay. Use a laser as the heat source, get a area up to molten temperature, add in the powder of what you want, and then move the substrate underneath that laser. In this respect, we can build up a 1 millimeter or 1.5 millimeter layer. And if you just keep doing that over and over again, you can build up a 1 centimeter or 2 centimeter thick cladding. We've got very good control over laser power, the type of powder you put in, and the rate of cooling as well. So you can customize and achieve a metallurgical bond to your substrate, as well as come up with quite complex coatings based on the powders that you're putting in. So these coatings in cross-section, if we have a look at those, they're a composite. So it has a metal matrix made up predominantly of nickel, some other materials as well, and normally a hard phase. So in this case, spherical tungsten carbide. In this respect, you've got the benefit of a relatively ductile matrix that can accommodate impact, but you've got a hardware-resistant spherical tungsten carbide. You achieve a balance between hard, brittle-like behavior of the carbide to stop abrasion, whereas malleable or ductile performance of the matrix to be able to withstand impact. So we would look at a range of different tests to evaluate the performance. We wouldn't just look at one. In this case, we've got CAIT, which is an impact abrasion style test up the top there. We've also got the 15 degree and the 90 degree represent erosion. So we're very interested at low angle and high angle erosion. We looked at electrochemical, which is the corrosion, the performance of the coatings in that respect, and then the G65, which is the sand rubber wheel to abrasion test. So we did other tests as well, but these were the key ones that we looked at for this slurry pump application. And depending on what sort of coating, the balance of the matrix to the hard phase, you could see a wide variety of performance. The white cast iron is the substrate, and you can see whilst it's very impact resistance, its electrochemical abrasion and erosion performance is poor. So applying any coating, you can get a performance increase, but tailoring a particular coating to a particular part on that slurry pump, you could increase the service life 2-3-fold. And it's through this understanding that we can tailor and enhance the coatings performance and in overall enhance the slurry pump's performance. So this understanding has been used by LaserBond across their operations to pick the right coating for the right application and the right application within the slurry pump. Another part of LaserBond's operations is repair and remanufacture. It goes to the heart of LaserBond's DNA. It's about not wasting anything, recycling, remanufacturing. In this case, it's a wheel spindle from a dump truck. You can see the top right-hand image there, the fretting wear that's occurred during the normal operation of the axle or spline. That was then machined off. And again, in this case, a metal alloy was laser clad over the top and then machined back to the original specification. So through this repair and remanufacture, a large expensive part can be turned around quite quickly and got back into service with minimal cost and minimal downtime. So that's the type of research and activities that a CRC can support. Where we see a real benefit of engaging with the CRC, and one of the critical functions of a CRC is to engage with SMEs. Within Australia, they've been shown to have a low level of international customers. They're resource limited. They have limited capacity to add to Australia's complexity index. And in some cases, they could be viewed as a weak link in a manufacturing ecosystem and supply chain. The SMEs have been reported that the lack of additional fundings can reduce growth potential. So just being able to keep up with the grant landscape is confusing. A lot of SMEs don't have time to be able to keep up with that sort of area and then miss out on a lot of opportunities. Access to skilled personnel is a predominant barrier. Again, that's where a CRC can help. And just the cost of developing and introducing any sort of innovation can quite often be too much for an SME to be able to handle. And that's shown in the sort of spending reported on R&D by small to medium companies. It's one of the lowest when compared to large enterprises. But the good thing is, a report by CSIRO showed that SMEs that can collaborate, they grow faster, they're more likely to introduce innovation, and they're more likely to have a higher turnover. And as we've seen over the last 5 years, uncertain times, the companies that can collaborate and partner can deal with uncertainty a lot better. So that's where a CRC can really come in. It can overcome those, it can have access to art researchers through the universities. The grant can overcome the dollar barrier, and the CRC can take care of the grant from an administration point of view. The SMCRC isn't coming out of nowhere. We're an existing training centre, which is another style of federal government funding. A training centre is all about identifying and delivering PhDs and masters, so higher degree by research students, linking them up with industry projects, and then graduating them so that they're highly skilled but industry relevant, and getting them out into industry to grow a sector. So that training centre was the Surface Engineering of Advanced Materials Training Centre, led by Swinburne, working with RMIT and us, UniSA. SEAM will wrap up in early 2025, and we don't want to see this cohort of great HDR students and really engaged industry partners just disappear to nothing. we think we've got a good culture, a good capability, and some really highly talented researchers that deserve a chance to do industry engaged research. And that's the vehicle to do that is the Surface Manufacturing CRC. We hope to get up to around 50 industry partners and have about 8 research institutes. So look at tripling the impact of what SEAM has been able to do. So what will the Surface Manufacturing CRC get up to? We've got a number of programs. Program 1, the actual surface manufacturing program, has the research in it, and I'll cover that in the next few slides. But because it's a CRC, it's a large conglomerate cooperative of like-minded industry and research providers. We can provide support across many projects or many companies in areas that can help grow your business or lead to opportunities where surface manufacturing can solve a problem or develop a new product. So one of those is defence readiness. We acknowledge that, well, certainly in South Australia and Australia, there is a growing opportunity for defence projects, and surface manufacturing can be critical in delivering new capabilities to defence, but also sustaining the current capabilities they've got now. So we'll have a support around that. The other one, an emerging area within industry and manufacturing worldwide, is Industry 5.0 and the ESG compliance. So that's environmental, social, and governance compliance. We see Industry 5 as a mechanism to implement and comply by ESG requirements. So we want to build awareness and help companies implement Industry 5 whilst doing surface manufacturing. The other one, Program 4, they're recognising that having 8 universities with 8 lots of key technical people, expertise, and equipment can support test and evaluation capabilities. We can support the standard development, and we can access or make it easier to access university equipment to do any sort of testing. We've got an accelerator scheme, which will be smaller projects that target lower TRL prototypes or demonstrators, or very high TRL that just needs a push over into commercialization. All CRCs need to have an education part to them, so we will be funding PhDs and masters. They'll be fully funded so we can target international students. That grows the skill base within Australia and hopefully plug some gaps that we're seeing coming up. We also recognise that there's this upskilling opportunity within SME staff. So we'd be more than happy to support staff within a company that are part of this CRC to upskill through a master's or a PhD, and to work alongside the project that's being funded by the industry partner to achieve the outcomes. So the research themes, we have 4. Some are more relevant than others to the current audience here, to the mining audience and the met sector. The top one, mechanical, chemical, and structural. So that's looking at the types of claddings and coatings that I talked about in the example previously for the slurry pump. Looking at tribo-corrosion, low friction or slip. We're also interested in low and high temperature operation. How can surfaces help sustain high temperature operation? Is of an area of definite interest and capability within our research partners. The other one for defence is life of type extension and sustainment of platforms. We have a biomedical and bioengineering section. We have electromagnetic and photonic section. That's representative of the capabilities within the universities, and we hope to be able to line up a few companies with those. And the research theme D, repair, reuse, and remanufacture. Again, that's using probably similar capability and a technical approach as theme A, the mechanical one, but it's looking at about it as in the qualification and certification of remanufactured parts. And that's delving into a layer by layer deposition process where we're reclaiming a damaged surface or building up a surface so that it can be fit for purpose. And that can support any areas in defence, mining, energy production, green manufacturing. Our research partners, at this point in time, we have 7. We were at Wollongong last week, had a great meeting with them, and they're really keen to be on board. We're talking with QUT as well. They may be the 8th university. We'll see how we go. But you've got Curtin University, well known in their corrosion centre, supports a lot of Western Australian mining companies. Swinburne with their thermal spray technology and Industry 4.0 capabilities. A really good range of capability there. We're also reaching out to other research organisations like CSIRO, ANSTO, the Australian Nanofabrication Facility, and Microscopy Australia as well. So the nuts and bolts and targets. We're going for a 10-year life. That means the CRC operates for 10 years. A project within the CRC can be anywhere from 1 or 2 years up to 3 or 4 or 5 years. We understand that no industry partner can really know what's going to happen in 10 years' time, but we hope that most SMEs and industry partners have a 5 to 10 year strategic plan. And this is the sort of CRC long-term grant funding that can really support that strategic research development. It can also be quite responsive as well. If you're a partner, if the CRC gets up, we hope to be able to turn around a successful project within 8 weeks, or even less if possible, sort of thing. So that's quite different to accessing other funding schemes where it can be 3 months to 6 months, even 12 months before the money gets released. So you sign up to the CRC to start with, perhaps with some ideas of projects in mind, but knowing that you'll have a pool of money that you can draw down on to fund a project and do really industry aligned to develop a new product or to solve a problem within your company. We'll be asking the government for up to $40 million worth of grant money, which will be leveraged off of around $30 million of industry cash. The more money that we can get signed up initially means that the more grant money that we can leverage off of the federal government and then build a really vibrant, large CRC. We see that the cash and in-kind from an industry partner really needs to be sufficient to drive a commercially relevant output. The government wants to see know-how and economic benefit released to the companies. Projects will be funded on a one-to-one basis, so $1 of your cash will bring an extra $1 of grant funding, which will give you $2 to spend within the project with an industry partner. Both the industry and research organisations will put in appropriate in-kind. As Peter said at the start of the talk, we won't hold any centre IP. The IP will be determined on a project-by-project basis, based on discussions between the project partners. We see for the education side of things, having HDR students closely aligned and allocated to active projects, and having those PhDs spend time at the industry partners' facilities, anywhere from 6 months to 12 months of extra hands-on training and experience, and generating data for their PhD. All right, the last dot point there, three-way preferred model. Within the CRC, we like the idea of having a three-way model where we would partner an SME that perhaps has a technology or wants to develop a technology, an end user that would be a potential customer or a pull-through of that technology, and then a research partner to help implement, develop, problem solve, technically transfer that process. So having the three-way partnership would be a preferred model within the CRC. We see that it de-risks it from the SME's point of view and the end user's point of view. And I've been involved in multiple projects where that's been the case, and it's always led to a good outcome. So the next steps, where are we going in this CRC proposal? So we're reaching out to industry right now, letting them know what we think is useful to the sector, but we want to hear from you. What are your challenges? What are your research interests? Is there alignment with what I've been talking about today? But is there something else that we've missed? A CRC is industry-led, so this is the opportunity for you to lead and let us know where the research needs to go. The round will open in December, but will close in March, and we have to get all of the application prepared by then. So for potential industry participants, we've got an expression of interest spreadsheet that we want to get in the next couple of months, and we would look to have, if the industry partner wants to go ahead, have a non-legally binding letter of support by the 8th of February next year, so that we can finalise the bid and support. Finish it off early March. Through the granting process, outcomes would be in 12 months' time, and then funding would start to flow early 2025, July 2025 at the latest, sort of thing. In between, early 2025 is when a legally binding commitment would be required. So this gives, it's long-term strategic research. You've got 12 months to plan that out and put it into your forward budgets, so that it can be accommodated. Wrapping up, I think I'm about 5 minutes early, so that's perfect. This is the current team, along with Professor Peter Murphy. Any one of us are more than happy to take questions or provide extra information, and we have a QR code there for that as well. I think that's it. I'm happy to take a few questions and start the discussion.
Great. Thank you, Colin. Thank you, Peter. Very informative. We do have some questions. So first up, are there any characteristics or track record that a METS company needs to have in order to get involved?
That's a really good question. I think they need to be solvent and have be in business for at least 12 months or 2 years. I think that's I guess federal government sort of requirement. Apart from that, no. I think a good industry partner is one that's engaged, has someone that's a project champion, and really wants a problem to be solved or a new product to be developed. I think that's probably, from us, that's what we look for, is people that are really are keen to engage and have an open mind around the approach sort of thing.
Sure. So you mentioned and gave an example of LaserBond. So they were obviously a partner with you in developing a technique that now they have, that they are an OSMINE member, which is really good, and they've been able to commercialise that, as I understand. Is that correct?
Yeah. So so they've been around for 20 years. They almost introduced laser cladding, certainly on a industrial scale and for repair and remanufacture. We've been working for them or with them for about 7 years now. We started with a CRCP, but then saw the benefit and built up a project for the IMCRC. That know-how is now underpinning a lot of the products that they're on selling to their customers and are in mine sites and mineral processing facilities. Yeah, and we've done some work on hot rollers for them as well, for the milling industry as well.
Great. So just another question here is, must all projects be surface related?
Yes, we are the surface manufacturing CRC. We see that as our key area of expertise. The research partners that we're working with are active in that area and have the equipment, capability and testing to be able to work at that surface. That said, we're happy to talk about additive manufacturing because it's a layer by layer approach. You're putting surface on top of surface on top of surface. If you get each surface right, you'll get your part right. But we do need to put a bucket or a scope around the CRC, and that is surfaces. Yeah.
Sure. So essentially, I'm a METS company with an idea, and I could reach out. I could put in an application to the university to be part of this Cooperative Research Centre.
So how it works, I think we're looking for partners now to sign up. We want to understand their problem or what they want to do, their strategy. We've got a nice spreadsheet, which is an expression of interest. So if they reach out, we'll send out this spreadsheet. More than happy to have a one-on-one conversation with them to talk about the sort of things that they could do, understand what they want to do. The spreadsheet is there to prompt them to look in to say, what do you want to do? What do you want to achieve? Who do you want to work with? And what's the impact? What's the outcome? They're the things that we need to put into the application to convince the government that this is a worthwhile grant or worthwhile sector to support. So that's what we'd like to be able to do. Fill out that form. If there's a really good overlap, we've found researchers that are aligned with that desire. We can talk about the sort of scale that project would need, the cash, the in-kind. We'd even like to do a rough budget just so that it's clear, establish some expectations from the industry's point of view, sort of what a rough idea of how much it will cost, rough idea of how long it would take. Then we can work out what the commitment would be for that industry partner. Then they can look at providing that letter of support. And then if the CRC is successful, we can start talking the nitty-gritty around project contracts and things like that.
Right, Colin. Just going to have to move quickly on this. Tax incentives.
Yeah, so the CRC system is registered for the tax rebate scheme. So any cash you put in is eligible for that rebate. So it can be quite a favourable mechanism to fund research or fund operations that need a research partner to help deliver. This is high TRL. It's not doing fundamental research at the university. It's about delivering economic benefit and industrial relevant outputs for industry. It's just that we recognise sometimes a company can't do that by themselves and they need to be able to partner to be able to achieve that.
Cool. Thanks. One more question. I'm nearly out of time, but when assessing a proposal from a potential partner, how do you take a position on technical risk of what's proposed?
We will have a risk matrix. I think there'll be a risk matrix. We'll want to see and understand what those risks are. It is research and development. The project contract will be a document that's developed by all partners. So all of the partners need to be comfortable with the risk that's being taken. It's research and development. Some things are unknown and some things should be risky.
Sure. Okay. I think that's all the time we've got for questions at the moment. But I'd like to give a big thank you to Peter and Colin and the University of South Australia Future Industry Institute for sharing their expertise today. This webinar will be circulated as an email link to you all, and will also be uploaded to OSMINE's YouTube platform. If you have any further specific questions for our presenters, please contact us here at OSMINE and we will put you in touch directly. Remember, an OSMINE webinar can help you market your business, product or service. Why not reach out to your local membership manager for more information on how we can help you. And finally, thank you to everyone who's attended today. Thanks once again to our presenters, Peter and Colin and the University of South Australia. We look forward to welcoming you to another OSMINE webinar soon. Please enjoy the rest of the day. Thank you.